Today is the last second day for you to talk something about the wireless technology. And of course, the same process before we talk about the detail of today's topic. Let's have a brief summary of yesterday. Yesterday, we talked something basic concept of the wireless. Includes in the wireless network, we will have some devices like the station, right? All the clients, they need the wireless network to wait the resources and need to get an IP address and get search some SSID. All the devices like the phone, like the laptop, like the pad, all these devices we call it station. And who can broadcast the SSID for them? These devices we call it AP, access point. And we can divide the network AP to become FAT AP and FAT AP. And yesterday we talked something about the FAT AP, right? And about the FAT AP, we can deploy in the small network or maybe some home network scenario. And all the FAT AP can allow the IP address, can broadcast the SSID, and we can add some simple security mechanism and then with the internet. So all the basic function we can deploy on the FAT AP. So in the some Soho scenario or some smaller network, we use the FAT AP is enough. And another one is if we in the bigger network, we if we deploy the FAT AP, we have to do the configuration one by one, and also when we do the troubleshooting, we also have to troubleshoot it one by one. So this is difficult. So in this scenario, we suggest to use another network mode. We call it FAT AP and AC together. So AC we call it access controller, and we can use AC to centrally manage the AP, and we can uniformly to do the configuration and to do the aggregation, and also we can check the status of the AP of all the APs. So this is another one we call is AC, and the other one we deploy FAT AP or maybe choose FAT AP and AC together. We have to deploy the distributed network at first, like this topology. We have to make a successful wired network, and then you can add the AP and the AC on the network. Then we can use the wireless technology. So this is another one. That's why last week we have 5 days to discuss so many technologies on the wired network. Okay, and then is once the AP help us to follow the traffic, we will also receive the message from the terminal and then to do the encapsulation. And we have lots of protocols in wireless technology. And all the wireless technology we call is AO2.11. And about the AO2.11, we detailedly explain the technology of the AO2.11n and AO2.11ac and AX. AO2.11ac we also call it Wi-Fi 5, and the AX we call it Wi-Fi 6. And we talk some detailed technology why the Wi-Fi 6 has higher speed than Wi-Fi 5, and why Wi-Fi 5 has the higher speed than the AO2.11n. And pay attention, this Wi-Fi 5 or Wi-Fi 6 we have the highest speed, but pay attention, your devices must suggest or must support the technology, although your AP devices and your client. Otherwise, this feature also cannot work. So this is a basic one. And about the FAT AP, we also discuss the detailed configuration, how to use the command to make the SSID and how to broadcast it. And also you have to give the configuration of the route and give the IP address. Then your AP can do the communication between from the terminal and then to the wired network. So this is yesterday we talked about the technology. And of course, pay attention about the FAT AP configuration. Yesterday we talked about the command, right? So maybe someone says the command is too difficult for you. It doesn't matter because when you buy the devices from the radio company, and also lots of I guess I think lots of AP or every AP can support the web page to finish the configuration. It's better for you maybe to you don't need to remember the command, but you have to know what the parameters meaning and gives good planning on your network, and then you can let your terminal to visit the internet. So it don't matter because I skip the configuration by the web page. I think it's very easy to understand. So I only explain the command for you because if you do the configuration from the web page, also finally will be translated to the command and then the devices will do the function. Okay. And today we will talk about two parts. One is the key point of the wireless technology is the fit AP configuration and the principle. Because now in our network, maybe media or bigger network, we will choose the fit AP and AC together. And what's the key principle, how to forward between the AP and the AC, and what's the principle to forward the traffic, and what's the key configuration here we have to do. This is the first part. And the second part, we will explain something about the WLAN roaming, because maybe someone already do the function on some RAY devices and click roaming and to enable enable it, or maybe you done this function on the radio cloud, or maybe someone makes a command configuration on the devices, but how to forward the traffic if we deploy the roaming, and what's the key point we have to know when we deploy the roaming in your network. So today we only have two topics, but this topic is very important and a little complex. So in this process, if you have any question, maybe you can write down and later we can discuss it together. So this is today two topic. And the first, let's say the basic one of the fit AP and AC together. This is the first topic, the AC and the fit AP principle and configuration. Because we say in our network, we can divide the mode to become FAT AP and the fit AP mode. And about the FAT AP, we explained the principle and the configuration yesterday. So today we will discuss something. Oh, sorry, I don't share my screen. It's clear now. Can you see my presentation now? Okay, sorry. At the beginning, I only discussed the topic yesterday and today topic, but I think it's doesn't matter for you about the presentation. But this part is very important for you. We will discuss the AC and fit AP principle and configuration. Because our network is divided to become the FAT AP mode and the fit AP mode. And yesterday we already discussed something about the FAT AP. So now we will know something about the fit AP. And about the fit AP, we have to work with AC together. So the key point, the key configuration, we all will down the command on the AC. So about this part, the first one is the fit AP configuration, and also we will explain some principle how to forward the traffic, and the key point of the fit AP and the AC is a CAPWAP tunnel. So the second part, we also will discuss something of the working principle of the CAPWAP. What's the protocol, how to work, and what's the detailed message exchange between the AP and the AC. First, let's see the fit AP architecture and pay attention about the fit AP. We have two forwarding mode. One is centralized forwarding and another one is local forwarding. In the working principle, I would introduce for you about the centralized forwarding. That means all the traffic will be forwarded to AC and AC then will help us to forward it. And about the local forwarding, because not every devices will support this feature. And at last, I will tell you what's the difference between the centralized forwarding and the local forwarding. And the detail I will tell you. And also about the local forwarding, we only add two different commands is enough. So the working principle, let's say the centralized forwarding, how to work. The first one, of course, the basic is wireless wired network is set up, includes VLAN, DHCP, and routes. Also, maybe in your network, it's very easy. The AP directly connect with the AC and with the switch, and then switch connect with the AC. But if your network is big, maybe this one is not enough, right? Maybe you will have the access switch, you will have the call switch. So before you deploy the Fit AP and AC in your network, you have to make sure that your wired network is set up successfully. That means you can ping successfully. And the second one, the AP starts without any configuration. You have to let the AP get an IP address and gateway address at first from the DHCP way. Also, you can use use a console interface to let the AP have the static IP address. It's also okay. And another one special for the AP is you also have to let the AP know where is your AC because we have to establish the connection with the AC. So how to make the connection between AP and AC? You have to let the AP know the IP address of the AC. And here we can have several ways to let the AP know it. And one way on the DHCP, we can use the special one for option 138. This is a special way to configure on the DHCP, and the option 138 will remember one AC IP address for the AP. And later, I also will show you the detail command. So this is the second one. And the third one, the AP will actively establish a CAPWAP tunnel with the AC. And pay attention, if we about the AP, if the AP get an IP address from the DHCP and know the IP address of the AC, we will try to establish the CAPWAP tunnel. Of course, in this process, we have lots of information have to check, like the version of the AP and some license limitation of the AC and something like this. If this message is successfully, then we will try to establish the CAPWAP tunnel. And the next step is after the tunnel is established, the AC will deliver the configuration to the AP. That's why we say if we use a Fit AP and AC together, the configuration of a Fit AP is very easy because we can get everything from the AC. And also maybe you have 100 AP or maybe only 10 APs. All the configuration you can get from the AC successfully. And the next step after getting the configuration information from the AC also includes one parameter of the SSID. Then the AP will broadcast the SSID, and later the station can associate with the AP and access the AP, and later we can let the AP help us to forward the traffic. So pay attention about this one. AP can get the configuration from AC, but how to broadcast it and this function belongs to the AP because about the AP we have the RF interface. So the station with the AO2.11 card, the network card, the wireless network card, we can search the information of SSID. That's why in your network, if you only have AC, it also cannot work. If you only have Fit AP, it also cannot work because you have to get the configuration from the AC. And after the station connected with the AC, then the AP can with the AP will help us to forward the traffic. I will receive the message from the station, and the protocol is AO2.11 because this is the wireless message. And then the AP will convert this AO2.11 to become the Ethernet. Because about AP, one side use electronic wave to connect with the terminal, and another side we will use the wired cable to connect with the wired network. And we have to forward the traffic from the station to the wired network. And about the wired network, we only can recognize the protocol like the Ethernet. So you have to convert the AL2.11 to become a Ethernet date. And then forward that to the AC because this architecture is a centralized forwarding. So about the AP, everything the destination will be AC, and then AC will help us to forward to the real destination. And the next step is the AC, how to forward us. So in the AC, we also have to add the routing configuration. And we have to let the AC have the routing information, and the AC will de-encapsulate the message from the AP and delete the tunnel header, and later forward the message to the real devices, to the real destination. And later, when the message reply, also the AC receive it, also have to add the CAPWAP tunnel header and then forward the message to the AP, and the AP will convert the Ethernet date to the AL2.11 date again, and then send the message to the station. So this is the whole process of the FIT AP. And in this process, pay attention. About this part, belongs to last week we discussed these technologies. And then about the AP get the DHCP, this also belongs to the last week. We talked something about the DHCP principle, but the special one is we will add one of the option 138. And the next step, when AP establishes a tunnel and gets the configuration from the AC, and this step AP will try to do automatically. And then we have to do is add the configuration on the AC. When AP asks to establish the tunnel with the AC, then AC can deliver the configuration to AP. So these are steps. And the last one for the forwarding process, AC and AP will forward the traffic using the CAPWAP tunnel. And this is the special way for the centralized forwarding. If the mode is local forwarding, we also have to establish the CAPWAP tunnel between the AP and the AC. AP also have to get the configuration from AC, and AC also can detect the status of AP and the client. But the different one is the forwarding plan. About the local forwarding, all the AP can directly forward the message out and to choose the best path. Because about the AP, we will have all routing information, and we never forward the traffic to the AC again. So this is a working principle. And then I will show you an example and explain some detailed configuration here. Like this topology, and we have the station, we have lots of AP and connect with the PLE switch, and then connect with the core switch, and this side we will have an AC, and finally to it the internet. Now we know the main working principle of the centralized forwarding. Then the first step we say a wired network needs to be set up successfully, includes how to plan the VLAN and how to deploy the DHCP and how to add the route information. Because finally we have to let all the terminals to bit the internet. And the key point of the core switch is the first one, we have to create the AP VLAN. For example, in here, we will use the VLAN 20 to let the AP belong to. And about the station, the VLAN is VLAN 10. We can divide different stations and in different VLAN with the AP. And the second one, we have to configure the gateway IP address and enable the DHCP. So in this example, the core switch will become the DHCP server in our network. And we have to let the switch allow the IP address for the station and also allow the IP address for the AP. All the AP also need an IP address. Then we can do the next step to do some message encapsulation and to forward the traffic out. And the special of the DHCP is Here, we not only to configure a normal DHCP pool for the terminals, but the other one on the DHCP pool for the AP, we have to add the configuration of option 138. And here is a configuration detail. And here I only show you how to configure the DHCP pool for the AP, the same configuration but different segment for the stations. First, you have to enable the service, the DHCP service, right? The command is service DHCP, and then you have to create the DHCP pool. For example, here the name is AP-address, and the special one for option 138, and the IP is a keywords, and this IP address 1.1.1.1, this is the IP address of the AC. And this IP address must exist on your network, and also the ping connection is successfully. For example, here in this topology, we use a loopback address as the IP address of the AC. Of course, you also can use a physical IP address, it doesn't matter, but you have to keep the connection is ready. And the next one, network 20.0.0, and the mask is 24, and what's your default gateway? And the other command is very easy to understand because when we talk about the DHCP principle, we already know the command function, right? And about the station, you also have to create another pool and give the network and the default router and also the DNS server address. And besides the DHCP, the core switch also is a gateway for the station and the AP. And we will use the VLAN interface, SVI interface, to make the interface IP address as a gateway. And about the SVI interface 10.0.0.254, and the mask is 24. This is the IP address, gateway address of the station. And another one for the SVI 20.0.0.254. This is a gateway address of the AP. So this is a key configuration of the core switch. Of course, how to get the switch, the SVI IP address, we also have to add the command of the core switch. Then the next one, between the core switch and the AC, if they located in different segments, we also have to add the routing information to let the message belong to different segments can be forwarded successfully. And about the core switch, we have to configure the static route of the AC loopback address. And the command is IP route 1.1.1.1, and the mask is 32, and the next hop is the physical address of the AC. And between switch and the AC, the physical interface, you also can use the physical one to give an IP address like 192.168.0.1, and another one is 0.2. Of course, you also can use some SVI interface as a layer 3 interface. So if about the switch, if we get the static route, we can send the message to AC successfully. And about the AC, we have to reply. So on AC, we also add a default route on the core switch, because about the AC, if we want to send the message to different segments, we only have one next hop. This is a core switch. So in this scenario, you can add the default route on AC. And the command is IP route 000, and the mask also is 0. Next hop is the IP address of the core switch. So in this scenario, when the core switch help us to forward the traffic from AP to AC, when I receive this message, I will directly send the message to AC. And the AC also can get some reply because we have the default route. This is the route plan. And another one for the AC, we also have to create one VLAN, but this VLAN only is station VLAN 10. About the AC, we no need to create VLAN 20 because later when we see the detail of the forwarding, we can talk about some reason why we only need to add the station VLAN 10 is enough. And about the access switch, we on the access switch creates the VLAN 20 of the AP belongs is enough. So in this scenario, the access switch connects with the AP. This port we only to give the access interface and to make the VLAN to become VLAN 20 is enough. So here is a question. The access switch is indispensable for the station data forwarding, but why no need the VLAN 10 is created on the access switch? Because about the station, if station connect with AP and then for the traffic out, first carry the VLAN is VLAN 10, and once the AP receive it, I will force the traffic out. And why the switch only needs the VLAN 20 is enough, no need to configure the VLAN 10. That's because between AP and AC we will establish the tunnel. And the station VLAN 10 will be like the service message and then encapsulated into the application layer. So about the access switch, I don't know the station VLAN, what's the detailed VLAN, and I don't care about it because I follow the traffic only according to the AP message. So this is a different part when we do the configuration on the wired network. Centralized forwarding about your access switch, you only need to give the VLAN for the AP VLAN is enough. But for the local forwarding, this interface should be chunk. Okay, should be chunk. This is the first step. And the second step, after the AP gets the IP information and also gets the IP address of the AC, then the AP will try to discover the AC and also try to establish the tunnel. And after we establish the tunnel, then the AC can give the unified management configuration and also the data channel established. So this is the second one. We have to let the AP know what's the IP address of the AC. And how to let AP know it? We have three ways. The first one also is the normally used way. We will use the DHCP and use the option 138 and to let the AP know the IP address of the AC. And another one, we also can let the DNS domain name know it. And for example, when you direct it to visit the message of the domain name ac.radio.com.cn, and then this domain name will be automatically translated to become a IP address, and this is the IP address of the AC. And the third one, we also can use a static way to directly configure the command on the AP to let the AP know what's your IP address of AC. So in this scenario, we suggest to use DHCP because maybe in the future your AC changes the IP address. We can direct it to change the command of the DHCP server. But if you use a static configuration on the AP, you have to change the command on each AP one by one. So we suggest to use the DHCP in your network. And the second one, once the AP starts without configuration, we will get an IP address and a gateway address from the DHCP way, and also get an AC IP address from option 138. So here is the configuration on the core switch, and then between the AP and the DHCP server, we will exchange the DHCP packets and get everything, also includes the AC IP address. So finally, AP will know my IP address is 20.0.0.1 and the mask is 24. My gateway is 20.0.0.254, and then I also know my AC IP address is 1.1.1.1. Then the AP will actively establish the CAPWAP tunnel with the AC, and the CAPWAP means control and provision of wireless access point. This is a special tunnel between the AP and the AC. So after we know the IP address of AC, then about the AC, we also have to establish the connection between core switch and the AC. One way we can use two links. One link only used for layer 3, use here, and then we can transfer the CAPWAP information. For example, now AP will establish the CAPWAP tunnel and send out the CAPWAP request. And the source IP address is AP address, and the destination IP address is AC IP address 1.1.1.1, and this message will be encapsulated into the UDP. And the special port number I will show you later. In your network, if you add the ACL on your network to keep the security, you have to let this port number pass through, otherwise the tunnel cannot establish. And then when the AC receives a message, okay, it don't matter. The last day after training, I will send the recording video. And when AC receives the request message, I will give the response, and the source will become the AC address, and the destination is 20.0.0.0, and also encapsulated into the UDP. And in the second part, I will show you what's the detailed information between the AP and the AC. And then, after the tunnel established, the AC will deliver the configuration to APs. For example, and about the AC, I will deliver the configuration to you, right? Includes what's the SSID, maybe your AP have to get. And another one, what's the WLAN ID and what's the VLAN ID, the mapping relationship. And also if in your network, you maybe add some security parameters. For example, to encapsulate to encrypt some message, and also to choose the radio channels. For example, the band you choose is 2.4 gigabit and which channel you can use. And also you can set the power per 100% or not. So the configuration you only need to add on the AC is enough. After establishing the tunnel successfully, the AC will immediately send everything to the AP. And then after the AP gets the configuration from the AC, then the AP will broadcast the SSID. Later, the station can search the SSID and connect with the AP. In this process, the station scans the SSID and joins the WLAN. Later, the station also the first step have to get an IP address from the DHCP server. And how to get the DHCP, how to get an IP address, the station will send out the DHCP request. This process is same we talked like the last week we talked it. And the message will be encapsulated into the AO2.11 header. This one is a little different because now we use the wireless cable to connect with the AP. And when AP receives this message, we have lots of things have to do. The first one, AP have to convert the AO2.11 date to become the Ethernet date because my upper devices is the switch. We use the network cable to connect with each other. So the first one, we have to convert it. And the second one, AP also have to add the VLAN tag. And this VLAN tag belongs to the station VLAN. Because about the AP, we already get the configuration from the AC. And if someone connect with this SSID, we also do the mapping, what's the VLAN belong to the station. So we have to add the VLAN tag. And the next one, AP have to forward the traffic to the AC because we use the way is centralized forwarding. And add the source IP address is AP and the destination IP address is AC. And then we will transfer the message to the next devices. The devices is a PoE switch. So later, once the AP sends the message out, we will get the information of the DHCP request of the station. I want someone to allow an IP address for me, and this is a AO2.3 header. We do the conversion. And the next one, we will add the service VLAN. This is a VLAN of the station, is VLAN 10. And we will add the CAPWAP header and also add the UDP header. This one is a tunnel information. And then we will add the source IP address is AP, destination IP address is AC. Finally, of course, we also have to continue add the source MAC address and the destination MAC address. And the source MAC address should be the MAC address of AP. And the destination MAC address is the MAC address of the AP gateway, right? Because now we need to forward the traffic between different segments. So in this scenario, the message will be forwarded out to the next hop, to the call switch. The PoE switch receives this message. I only forward the message out according to the MAC address information. And when the call switch receives it, because the destination MAC address is myself, so I will delete the source and the destination MAC address, and then take the destination IP address to check my routing table. And I will find the destination IP is 1.1.1.1, and I already add the static route, right? And the static route next hop is the IP address of the AC. So I will directly take this message to AC. Okay, to AC. So this is a process between the AP and AC. I now use the message sent to the AC. And when AC receives this message, I also have some actions we have to do. The first one, if we receive the DHCP request of the station, from the CAPWAP tunnel, and then the AC will learn the MAC address entries of the station through the CAPWAP tunnel. So about the AC, we also have the MAC address table, and the source MAC address is the station, and the outer interface is the tunnel interface. This one is special. We don't use the physical interface. We will use a CAPWAP tunnel. And also we will force the Ethernet date according to the MAC address table, and then to use the VLAN 10 because this message already connect with the VLAN 10. Then later we will send the message to call switch because this is a broadcast message of DHCP request, and the VLAN is VLAN 10. The de-encapsulate Ethernet date is a broadcast message. So the packets will be broadcast all the interface in the VLAN 10, includes the trunk VLAN connect with the call switch and the AC. So about the AC physical interface, that's why we say this interface must allow the VLAN 10 pass through, because about the AC, when we receive the message, we will carry the VLAN of VLAN 10. And why we don't need to allow the VLAN 20? Because when the call switch first time receives this message, I already delete all the VLAN information of the VLAN 20 and send this part information to AC. So AC never know what's the VLAN of the AP, but I have to forward the message of the service VLAN 10. Okay, I will send the message to call switch. About the DHCP request message. Why I have to delete this message? Because I know the destination IP address belongs to myself, so I will delete it. And then I will find this is a CAPWAP tunnel. I am the one side of the tunnel, so I also will delete it. And then broadcast this message to all the interface of the VLAN 10, includes the devices of the call switch. So pay attention. In the centralized forwarding architecture, a layer 2 channel must exist between AC and the call switch. The call switch is a station gateway because we have to broadcast the message to call switch and then get the DHCP response. And later, the AC also will forward the data returned from the wired network to AP through the tunnel. Now we already sent the DHCP request to call switch, and the call switch will do several things. The first one, the call switch will update the MAC address table of VLAN 10 because now I receive the broadcast message from VLAN 10. And the next step, the call switch will allow an IP address in the address pool because this is a function of the DHCP request. Then the call switch will returns a DHCP response from the trunk interface. Okay, And here I will show you what's the IP address you can receive. Then the AC will give the reply to the AP use the tunnel interface. Okay, use the tunnel interface. The message will be encapsulated again at the AL2, the 3 header, the VLAN is VLAN 10, and at the CAPWAP header at the UDP header. And the source IP address will be the IP address of AC. The destination IP address is AP IP address. So finally, the station will get an IP address. And after we get an IP address from the switch, the AP will forward the DHCP response to the station to let the station get an IP address. And in this process, we also have to convert the AL2 to 3 header to become AL2 to 11 again, because about the station we only recognize the wireless packets. So this is the whole step how to forward the traffic between these devices. And also after we get the IP address later, when we do the waiting to wait the internet resources, we also like this process. I will send out the message to AP. AP will help us forward the traffic to AC, and AC will help us continue forward the message to the destination. So how to let the devices working like this principle? We have to add the configuration here. And the configuration step is the first one. We have to determine the deployment position and the connection mode of the AC based on the wired network structure. And the second one, we have to prepare an AP information table. We have to write down every information of the table, like the position places, the physical places, which floor, in which room, and what's the number, and what's the AP name, the MAC address, what's the SSID we gave for the AP, and what's the VLAN we designed something for them. Also the VLAN for the AP, the VLAN for the stations, and which PoE interface we connect with the AP. And everything we have to record it. And later we have to perform the DHCP planning and the routing planning. Then the key point of the AC is configuration. The first one, the interface and the route of the AC. We have to make the communication between the wired network. The second one, we have to upgrade the AC and AP software. And then the AP can join the AC and establish tunnel successfully, gets the configuration from the AC. And we also have to complete the AP configuration on the AC and use the PoE switch and supply the power for the AP. Then the AP gets the power. I will direct send out the DHCP message to get an IP address and also get IP address of the AC. Then we try to establish the next step. Then we will summarize the WLAN devices configuration. So here let's see the step 1, how to determine the deployment position of the AC and the wired network. Because in this topology, the core switch will become the wired and wireless gateway, includes the station and the AP gateway. And all the message will be sent to the AC at first, and then AC will give the reply to the core switch. So between the core switch and the AC, we have several solutions. We can use the layer 3 interface to forward the CAPWAP tunnel data, and also we need a trunk interface, and then this link will be forwarded to layer 2 data from the station in different VLANs. Like the example, the AC have to broadcast the DHCP request message to the core switch. So here we can divide two links, one as a layer 2 interface, like the trunk interface, and another one for layer 3 to forward the CAPWAP tunnel data. And pay attention, why here we use the VLAN, we use the trunk interface, because we say trunk we can allow multiple VLAN pass through, right? And we see about the AC, we no need to let AC know what's the VLAN of the AP. But why we still have to use the trunk? Because in your real network, maybe your different departments have different stations, and we will divide them to become different VLAN. In this scenario, AC have to working provide the service for several departments for several VLAN. So this VLAN, all of them belong to the station VLAN. That's why we will use the trunk interface. If you only have one station VLAN, here you use the access is enough, and this VLAN should be the VLAN of the station. And also we can use one link and use the SVI interface of between the core switch and the AC. So all the CAPWAP tunnel and the layer 2 tunnel between the core switch and AC, we can use one link. So two solutions, all of them can be used. And then the core switch and the AC, we have to add the routing information. And the second one, we say we have to prepare the AP information table and to write down what's the AP name, the MAC address, physical address, something like this. So if one AP cannot work, we can immediately check the table and find the places and then to replace the AP immediately. So this table also is very useful. And the next step, the DHCP planning and the routing planning. The special of the DHCP is we have to add the option 138 to show the AC IP address. And here, core switch have to add the static route to wait the AC loopback address because the core switch have to help the traffic of the CAPWAP tunnel. The destination IP address is the loopback IP address of the AC. And about the AC, we can add the default route, and the next hop is a core switch. And the core switch is a DHCP server. We have to create at least two ports, one for AP and another one for station. And in the AP, special one is we have to add the option 138. This also is the first key point on the fit AP. If you give the wrong IP address, or maybe between the core switch and the AC, the TCP connection is disabled. You cannot establish the tunnel successfully, and finally you can find your AP is offline. So this one is very, very important. You have to deploy the successfully routing information at first, and then to let the AP know what's your AC IP address. And about the AC, we also have to add the default route, and the next hop address is a core switch IP address. And here is a key configuration on the AC. You have to know it. The first one, you have to define the WLAN on AC to create the WLAN configuration, and the requirement is create the WLAN ID is 10 and add the description is VLAN 10 and the SSID name is @radii. And the command is WLAN configuration 10. And here the 10 is the WLAN ID. And this ID is very important. Maybe in your AC you have several AP groups, so you have to use different ID for different group. And the VLAN 10 is a description. If you don't add the VLAN 10, it also can work. And on the WLAN configuration, we will add the SSID. The name is @radii. And then we will use the command band selected enable. This is a command to enable the broadcast function. The command is different with the FAT AP. And then we have to create the VLAN. And the VLAN is VLAN 10, name is the station. And add the interface VLAN 10 IP address is 10.0.0.253, and the mask is 24. And add the loopback interface. The loopback interface is 101.101, and the address is 24. And here we create the layer 3 SVI interface for the wireless station VLAN, because we also have to do the communication between the station and the AC. So this is a configuration, but this address is not the gateway address of the AC, of the station. The station gateway address located on the core switch. And another one, we have to create the AP group. Pay attention about this part. We have to define the group because we have to provide the mapping relationship between the WLAN and the VLAN. Why is the station connect with this SSID and belong to the VLAN 10? Because we provide the mapping relationship on the AP group. So create the AP, the name is region 1 flow, and the interface mapping 10 and 10. And about the first 10 is a WLAN ID, and the second 10 is a VLAN ID. And pay attention, this ID must be same with the WLAN ID you create, because on the WLAN ID configuration, we have the command to create the SSID and broadcast it, right? And of course, this VLAN, this WLAN ID, you can use ID like 5 or 6 or 1, it doesn't matter. But that means this two value can be different. It also can work, but this WID must be same with this ID. Okay, and the second one is the VLAN ID. And the later is the radio information. This is the optional configuration. The radio ID is involved in the mapping. By default, the mapping involves all radios because maybe in your network, your AP can support two bands, one for 2.4 gigabit and another one for 5 gigabit hertz. By default, if you don't choose these two radio interface will get the configuration automatically. If you define for one radio, maybe only one band can broadcast this SSID, and the other, like 5 gigabit, maybe cannot use this configuration. So this is the AP group. And then you also have to enable the PoE function on the PoE switch to let the AP get an IP, get the power, and then we can send the message out. So how to enable it? Enter the interface PoE enable. And then you also have to make the access VLAN and the VLAN to become 20. Okay. So in the centralized forwarding scenario, the PoE switch we only allow the AP VLAN is enough because your station VLAN will be encapsulated within the message. So the PoE switch don't know any information of the station VLAN. So access VLAN is enough. And then you have to add an AP to the group. Wait until an AP establishes a CAPWAP tunnel of the AC. Then we can get the AP information by the warning, like this one. If AP gets the power and send out the DHCP request and get the AC IP address, then the AP will try to establish the relationship with the AC and establishes the tunnel successfully. On the AC, we can see the warning information, like this one. What's the time? We receive the information and what's the IP address, what's the MAC address, and the status now is up. And we attach to the AC successfully. Then you can create the AP configuration, and here is the MAC address of the AP. And the radio type 1 chooses the protocol L2.11n. We use this protocol for the radio type 1. Radio type 1 is 2.4 gigabit. And the location default. And the AP name to change to become AP1. Otherwise, the name you have to record like the MAC address. It's too long for us, right? And then you have to add the AP into which group, like the group we created before, region 1F. So the AP can get the configuration from the AP group. And in the AP group, we already provide the mapping relationship with the WLAN ID and the VLAN. So in the configuration of the Theta AP, we divide the different part into different parameters into several parts. And then in different scenario, and for example, in the AP group, you can make lots of parameters together to combine with them. And the first, the red one is the AP name, which is the MAC address of the AP by the default. Also, you can change the name to become AP-1. And then you can choose the operating band of the radio and the value of 2.4 gigabit by default, and it can be modified. And pay attention, yesterday we talked something about the AO2.11 protocols, and several protocol only can be used to 2.4 gigabit, and several protocol only can be used in 5 gigabit. So pay attention about this part. And if you want to your network more security, you can add some security parameters of the WLAN, and the key configuration is the WLAN SEC. And here is the WLAN ID. And this ID, pay attention, must be same with your WLAN config ID. This one must be same. For example, first you create the WLAN config ID is 5. Here you also have to use a 5 because they will automatically connect with each other by the number. And we have to choose which algorithm you use, the ISN or the other one. And pay attention, here we can see lots of security algorithm. And your configuration is only to choose which algorithm you want to use. Different algorithm, we can protect a different message for more security or less security. And you don't need to know what's the key point and what's the principle. And you have to know is which algorithm is more security, which one is less security is enough. And higher security, it's better to help us to protect our traffic, but more resources for the devices use. So pay attention about this one. And another one is what's the key value we will use on the security, like the number of 1, 2, 3, 4, 5, 6, 7, 8. This is the value we have to do the configuration. The other one we only need to enable the algorithm is enough. So later, when we do all the configuration on the AC and the AP gets the power successfully, establish the tunnel successfully, get everything from the AC, we can use the command show CAPWAP status, and then we can check the status. If the status to become wrong, that means the tunnel is established successfully. If we use a command to check the status and the status not wrong, maybe there's some reason. The first one, we have to check the AP can get the power successfully or not. Otherwise, you have to check the PoE switch. If your PoE switch is not working normally, or maybe you don't enable the PoE function on the switch, then the AP cannot get the power. The second one, maybe after the AP gets the power, the first step is I have to get the IP address. So this also is some scenario that maybe your wired network there's some problem, and then you cannot get the IP address successfully from the DHCP server. Maybe the data also will be done. And the other one, like the routing information between the AP loopback address and the AC loopback address is reachable or not. Otherwise, the tunnel also cannot establish successfully. So this is the configuration and the check. And another one, you can use the command show AP config summary, then to check the AP detail information, and you can see how many online APs and how many offline APs, and what's the online AP detail information, the name, the IP address, the MAC address, something like this. If you use the command to change the name, the AP name will be another name, will not be the MAC address. By the default, the AP name is a MAC address. And what's the radio status? And what's the channel now we use? The 6 and 153. This is a 2.4 gigabit and 5 gigabit hertz channel we use finally. And what's the power? 100%. And up or offline what's the time? Now the data is wrong. So we can use the detail to check the AP information. And we also can check the client, the station information, show AC configuration client, and how many stations online now, what's the MAC address, IP address, something like this. So these are commands we can check. And here are the summary how to do the configuration. The first we have to keep the where the network structure is successfully. And we choose the way to become the centralized or local forwarding mode. And about the AC and the AP also can run the CAPWAP tunnel based on the layer 2 or layer 3 network or maybe the permeation net. And then the tunnel will be established two parts, one for control tunnel and another one for the data channel. And the control tunnel is used to like upgrade configuration and RF management for the AP, and the data channel is used to follow the traffic. And how to establish the channel, this also will have several minutes or several seconds. Like the first one, get an IP address about the AP and discover the AC and request the drawing and upgrade and get the configuration. These are whole step how to establish the tunnel. And about the centralized forwarding, the different one for the data flow have to pass through the AC, and the AC will de-encapsulate the message and forward the message out. So in some scenario, you choose a centralized forwarding. Maybe there is a performance limitation in your network. And about the local forwarding, the data flow does not pass through the AC, and no CAPWAP tunnel is established. And this no CAPWAP tunnel means no data tunnel will be established, but we still need the control CAPWAP tunnel to get the configuration from the AC. So this is a configuration summary. And here we also record the detail when we do the configuration. The first one, we will create the WLAN config. And here we can add the WLAN ID, right? And one ID, you can create more SSID and give the SSID detail. And also we have to create the VLAN, create the VLAN number, create the SVI interface. This VLAN for the station VLANs. And both of them have to correlated with each other. And this information we will do on the AP group. So on the AP group, we will combine the WLAN ID and the VLAN ID together to let the station know if the station connects with the SSID, I will know what's the VLAN ID I will use. And another one, this is an interface mapping. And another one on the AP config. After the AP gets the configuration from AC successfully, then we can change something for the AP, get the AP MAC address information from the warning, and you can use the warning information in the AC, get the MAC address of the AP, and according to the AP configuration, we can change the AP name to make more easy to remember the AP information, like the AP-1 or AP, the first floor, first room number, something like this. And on the AP group, we also can get some configuration of the radios, and also like the channel, like the bandwidth, like the power, and so on. And another one, we also can, maybe someone say, I have to do the upgrade for the AP, or maybe I want to control some, to give some configuration for the AC. And about this part is the configuration of the AC controller. And here you can give the AP firewall management and also can change the AC name. Of course, if you don't give the configuration here, we will have some default configuration. And then the AP config and the version information from the AP will be setting on the AP. If the AP establishes the channel successfully with the AC, and we can get the configuration. And another side is if you want to let the AP to protect the traffic for your network, you can add some security configuration. And here we will add the configuration on the WLAN security side. And about this part, we need one WLAN security ID. And this ID is same with the WLAN ID. So if you want to add the security configuration, you have to configure WLAN config at first. Then you can choose which protocols you want to use, WEP, SPA, ISN, and so on. And of course, for the authentication and encryption, also maybe we can prepare a training. We have lots of protocols and the detailed information can discuss. So that's all about the physical configuration. Maybe you have to do on the AC. About AP, you don't need to add any one, only to get the power and then get an IP address. Then we will get everything from the AC. Of course, before the AP establishes the channel with AC, you have to add the configuration on AC at first. So someone maybe say, AC and FIT AP, the configuration and the principle is a little complex. That's because we divide all the parameters to become several parts. About the FAT AP, it's very easy. Everything we directly add in the FAT AP is enough. But about the FIT AP and the AC, we have to divide several, and then you can combine different parts together, depends on your requirement. So this is a configuration summary. And any questions here? It's easy for you to understand now. Of course, in this training, I only talk about the main principle and the main command to you, not to show you the practice guide, right? The lab guide. In the future, we also will prepare the detailed scenario and what's the step one by one, and to finish the practice. In the future, we will prepare it. Okay, so this is a principle. And the next step is a working principle of the CAPWAP. Because about the configuration, we add so many information on the AC. Then how to get the information from the AC? We will use a CAPWAP tunnel. And how to force the traffic? We also will use a CAPWAP tunnel. So about the working principle of this part also is very important for us. And later when we talk about the roaming, also have a big relationship with the CAPWAP tunnel. So about this part, maybe let's have a break, and 15 minutes later, let's come back. We will continue to discuss about the CAPWAP tunnel and also about the roaming part. 15 minutes later, also same, if you have any questions about this part, please write on the chat window and I will see the detail and discuss later. Okay, so first part, we discuss something about the FIT AP configuration, right? And the key point between in the centralized forwarding mode, we have to establish the CAPWAP tunnel between the AP and AC. Thank you, guys. So the second part, let's see some working principle of the CAPWAP. CAPWAP is a control and provision of wireless access point protocol specification. So this is a special protocol for the AP and AC, and actually we have lots of steps between them. If here is AP and we have an AC in our network, and we have two CAPWAP tunnels, one for the control tunnel. And about the AP, we will have an IP address. For example, we create the SVI interface 1 for the AP, and the AP use a port number 10,000 to make the establishment between the between AP and AC. And about the AC, we will use the special UDP because as a previous presentation, we see all the CAPWAP message will be encapsulated into the UDP. So the special port number is 5246. In your network, you have to allow this port number pass through. And what's the IP address we will use to establish? One is we can use the loopback 0 IP address of the AC, or maybe we can use the command CAPWAP cultural IP, and to give a special IP to establish the tunnel. And then they will establish the first tunnel we call is a control tunnel. And the function of the control tunnel, we will use this tunnel to upgrade the AP versions if the version is not the newest. Or maybe we will deliver some configuration through the control tunnel. And another one, we also AP will use the same IP address but different port number to indicate the data tunnel. And about the AC, we will use 5247 to establish the data tunnel, and also use the same IP address. And about the data tunnel, we will use this tunnel to transfer the station message, includes the internet access message and the relevant station data, for example, like the DHCP message. So this special port number you have to know in your network. If you deploy the ACL, you have to allow to permit this port number pass through. And another one is about the CAPWAP. We have two tunnels, one for the control to relationship of the AP version, the AP image, and the configuration. The second one, after we get everything configuration from the AC, we will help us to help the station to follow the traffic, and we will use the data tunnel. And the data tunnel only will be located on the centralized forwarding. And here is the establishment. What's the step and what's the process to get the tunnel establishment. The first one is the AP should get an IP address. And the second one, the AP have to discover the AC. This is a discovery process. Then the AP have to join the AC, and then the AP have to automatically upgrade it. Of course, maybe some AP not have this process because the version is matched with the requirement of AC. And the next step is the configuration step. The AP will get the configuration from the AC automatically. And the next step is a date check. We have to check all the configuration synchronized successfully. Then the last step, the data is forwarding through the CAPWAP tunnel. And finally, we use the command to check the state will become wrong. And in the other process, we also can use a command to check the media process, to check the media status. Then let's see the detail in each process. What's the main work we have to done in this process? The first one, we say AP have to get an IP address, use the DHCP. So about the AP, first one, we can use a static configuration, and here is a command. You can use a console link and connect with the console interface of the AP, and to give an IP address for the AP, and also to tell the command what's the gateway. AP IP, IPv4, and the IP address, mask, and your gateway. And also you can use the command to let the AP know who is your AC in the 1.1.1.1. So this is a static configuration. And about the DHCP server, we also can let the DHCP server allow IP address for the AP and the IP DHCP pool. And this command we already talked before, so this part we will skip it. After we choose the process, we choose a way to use the DHCP get an IP address. Then after the AP gets the power, I will send out the DHCP discovery. Of course, if you choose the way to use the DHCP get an IP address, the AP connected with the PoE switch gets the power, the AP will automatically send out the discovery message. And then the DHCP server will give the reply of the offer. And the the AP will get the request to make sure that this IP address can be used or not. Then the DHCP server will give the acknowledgement. And this process, the detail part, we already discussed last week. So about this part, we also will skip it. So in this process, the AP will get an IP address from the DHCP server and also know what's the IP address of the AC. And the next step, the AP will discover the AC. The first step, I only know what's the IP address of the AC. I have to check the AC exists and I can establish the tunnel with the AC. So in this process, the stator will become idle because now I don't have any information of the AC. The same status of the AC, because on the AC you also can check the status of all the APs. Then the AP will send out the discovery message, and this discovery message belongs to the CAPWAP protocol, not about the DHCP. Pay attention about this one. And about the AP, we will send out three types of message. The first one is a broadcast message. The second one is a multicast message. And these two messages will be sent out automatically by once the AP gets an IP address. You don't need to give any configuration. If in the same layer 2 segment, there also is an AC, and the AC will give a reply. And the third type, we will send out a unicast discovery request message. And this message destination is 1.1.1. This is the information we get from the DHCP server. So I will send out the unicast message. And the next step, after we send out the discovery message, the status will become discovery. And then the AC will give a reply, and the source MIC address will become the 1.1.1.1. And pay attention about this part. About this AC, we have two IP addresses. One for 1.1.1.1, this is a loopback address, and another one is a VLAN1 SVR interface 192.168.1.1. And what's the source IP address will be reply. The first one, you can use the command to change it, AC controller, and change the culture IP to become 192.168.1.3. If you add this command, I will use this IP address as a source IP address to establish the connection with the AP. And then AP receive it, I will record I have one AC, the IP address is a culture IP address. And of course, I also will add the IP address of the AC from the DHCP server. And if the AP, on the AP, you use the command static way to add the IP address, to add the AC address of the AP. On the AC list, I also will record it. That means about the AP, I will have an AC list. I will write down every way I get and what's the IP address value from the AC. And of course, different AC we will have different priority. Like the static priority is higher than the dynamic and higher than the broadcast. But about the discovery process, I will write down everything. I can get the information from the AC. Okay, so if you add this command about the AC, maybe we will have two message. One for the source is 1.1.1 and another one for source is 192.168.1.1. And here is some mistake of the command. This IP should be 1.1. Okay, not about 1.3. That means I will use this IP address as a reply for you. The data will become DTLS setup. And the next step, after we give the reply to you, and I know in our network, that we have the AC exist, and I will take this data to indicate I already get the process of discovery. And then the AP will choose to join one AC. In this process, I will choose the highest priority of the AC. That's the process we say the static way is better than the dynamic than the DHCP option 138 way, and also has higher priority than the dynamic like the broadcaster or multicaster to get an IP address from the AC. Then I want to join the highest priority with the AC. And before we join it, we will establish the DTLS link. And in the DTLS link means we want to do some encryption for the REST communication between AP and the AC, so we can protect the traffic between AP and AC. So they will establish it and automatically. Then the AP will send out the join request message to AC, and AC will give a response. Okay, you can join or not. Then your data will become join. And later, maybe the AP will find that the version is not matched with AC requirement. So the AP will send out the message, I want to do the immediate request, and then the AC will give response. So the AP requests for an upgrade. Then the AC will give you the special version you can use, and the AP gives the response, I receive it, and the AC delivers the main program for the AP. Of course, some scenarios the AP will skip this process because the version is ready. And the data will become the immediate. And then the next step, if the version is successfully, of course, pay attention. If the AP gets the version from the AC successfully, the AP will reboot automatically. So the AP will get an IP address and the discovery and join again, and later to enter this process to get the configuration. Then the AP will send out the config data requirement. Please give me the configuration, and the AC will give you the response. Check the data. The data will become config. And then the AP will give the change data event request to show you now I get every configuration from you, and AC will give you the response. And in here, we will establish the tunnel. And about this tunnel, pay attention. The last step, the data will become the date check. And later, we will send out the keep alive message every 30 seconds. And this message sent out will show you now I am ready to establish the tunnel for you, and the AC also will give the reply in every 30 seconds. The date tunnel is established successfully. And also we will use the echo message to keep the communication all the time with the AP and AC, and finally to establish the control tunnel. And after we exchange the keep alive message and echo message, later the data will become wrong. So finally, we will find the AP is online successfully. And in this whole process, maybe main three parts we will have some problem is the first step, maybe you get an IP address wrong, or maybe you cannot get the AC IP address. The second one is between the AP and AC, when we do the upgrade, and you will check I can get an IP address, but I still cannot go online. Maybe you have to check the license of the AC. Maybe this is a number limitation of the AC. And the next step, after we establish successfully, finally you can check the data will become wrong. And you also can see two tunnels, one for the date tunnel and another one for the control tunnel. This is a process. And after we establish the tunnel successfully, then the AP can help the station to follow the traffic. And we have two modes, one for centralized forwarding Centralized forwarding means all the message will be sent to the AC, and AC will help us to forward the traffic. So about this forwarding, let's see the process. Now, if the if the station want to send out the message, for example, maybe the destination my IP address is 8.8.8.8, and the source IP address is the IP address of the station 192.168.2.2. This is the date we call as date 2. And the message sent to the AP, AP will add the tunnel information. That means we will add the source port number and the source destination port number. One is 1001, one is 5247. And also continue to add the source IP and the destination IP. The source IP is the IP address of the FIT AP 192.168.1.3, and the destination IP is 1.1.1.1. And continue to encapsulate the message to add the source MAC address of FIT AP. The destination MAC address is FIT AP gateway MAC address. So about this part, we can take the station message to become date 2. And after we add the tunnel information of the message, we call this message is day 1. Later, the data will be forwarded from the station to the controller. And then the controller will delete the header information for these 2 parts, and then forward the day 2 information to the destination, to which the internet. So this is a process. After the message reply, the day 2 also have to reply to the AC at first, and then AC will forward to the station. So this is a centralized forwarding. And in this forwarding, when we plan the VLAN, pay attention about the core switch and the AC switch. We have to use the trunk port. We have to enable the VLAN 2 for the wireless VLAN. Why we use to the VLAN? Why we use the trunk port? Because maybe about the other station we will use a VLAN 3 or VLAN 10 or maybe VLAN 20. So that's why we use the trunk VLAN. And about the permit list, we allow all the VLAN from the station, not about the AP. And another one for the PoE switch, we only need the access point is enough, and the native VLAN is the AP VLAN. Okay, so about this part, no need to configure to become trunk. Of course, if you configure trunk and make the native VLAN to become the AP VLAN, it also can work. Okay, pay attention about this part. And another one for the local forwarding. And about the local forwarding, of course, the same process. The station now want to wait the destination is 8.8.8.8, and the source IP address is 192.168.2.2. This data we call is day 2. And the message sent out, I can immediately, about the FIT AP, FIT AP can immediately choose the best path and send out to the destination. And this message, no need to forward the controller again. So about the local forwarding, we can select the best path. And about the AC, there are no limitation of the performance of the controller, because the AC no need to help us to forward the traffic again. So this is a local forwarding. But the disadvantage is your FIT AP. You have to get the routing information and to select the best path. Okay, so this is the disadvantage. And of course, your FIT AP have to support this feature at first. This is a local forwarding. And when we do the planning of the local forwarding, the PoE switch must set to the trunk port, and the native VLAN is the AP VLAN. But we have to enable the VLAN 2 of the wireless station. This should be the trunk port, And you also have to let all the station's VLAN pass through, because the PoE switch will immediately or directly to forward the station message. And about the link of PoE switch and the core switch also should be the trunk switch. You have to enable the VLAN 2 of the station and also the AP VLAN, because all the AP message will be sent out to pass through the link, and the station VLAN also will be sent out. So that's all about the Fit AP and the AC. About this part, we have lots of time. We have much time to discuss the principle and the detail how to work of the CAPWAP tunnel and what's the key configuration of the AC. Do you have any question about this part? If you have, maybe now you also can open your microphone or maybe write down so we can discuss together now.